Underground tanks got a bad reputation in the 1980s as secret pollution sources that endangered public health and were very costly to own if they leaked, which they often did. The current technology is safe, and the regulatory scrutiny during installation is keen, so that these pollution problems rarely exist now. Most commercial fuel in the U.S., primarily in retail service stations, is safely stored underground.
Underground storage tanks are fiberglass or steel composite that are almost always double-walled. Steel tanks have a steel inner shell with a fiberglass or urethane outer shell. Some have steel inner shells and a secondary shell with a fiberglass or urethane coating on the exterior of the secondary shell. The interior is usually uncoated, although optional interior coatings are also available. Both types of tanks are common and in a competitive price range. The relative price between the tank types depends upon the location and price for steel and petrochemicals at the time. Regulatory requirements govern the accessories for underground tanks to prevent leaks from tanks and piping. Tank sumps are perhaps the most important, yet the most troublesome accessory. They allow for the installation and servicing of tank equipment such as pumps, valves, and instruments, as well as for the connection of fuel piping to the top of the tank. Manhole frames and covers are designed to allow access to the tank sumps while allowing surface traffic loads to be transferred to the surrounding ground without affecting the sump or tank. Lightweight sump covers or lift-assisted covers are preferred for safety. Vent terminations allow the tanks to stay at atmospheric pressures as the fuel level changes. Their primary purpose is to disperse vapors, exclude water, and prevent intrusion from insects or birds. Tank fill hardware attracts a lot of attention because of the chance for spills and overfills during fill operations. Spill containers of 5 to 15 gallons surround the fill pipe to catch any spilled fuel when delivery hoses are disconnected. The fill pipe adapter and lockable cap make for a tight hose connection to the tank to prevent leaks. The fill pipe drop tube directs fuel to the bottom of the tank to minimize vapors within the tank. The overfill prevention valve is installed within the fill pipe drop tube to stop fuel inflow to the tank at a level below 90%. The valve is a mechanical device that operates with a float rising to close the valve. Submersible pumps are installed within sumps to provide fuel transfer to the point of use. The pumps include devices to regulate pressure and to determine line leaks that stop the pump flow if a leak is detected. Most suction systems with remote above-ground pumps utilize foot valves. The foot valve is a check valve installed vertically at the bottom of the suction pipe within the tank. It maintains the suction line full of fuel to assure pump prime. Extraction fittings are often used at the top of the tank connections for the suction pipe to allow removal of the pipe and foot valve for inspection and servicing. Electronic level gauging equipment consists of an electronic transmitter, typically a float traveling on a stem based on a mag principle for accuracy. The tank should have access for manual gauging using a wood measurement stick. Continuous electronic leak detection is provided for underground tanks, sumps, and piping. The most common user problems are failures of secondary containment. These generally occur because of ground movements from surface loads, settlement, or freeze-thaw action. The design can address this problem by specifying good quality equipment from the major manufacturers. The second important design concept is to design for redundancy. Typically, a failure of underground tanks is a failure of periodic piping or tank sump tests. When a test failure occurs, that portion of the system will need to be removed from service for repair. It is important that the design address this reality, and that this is accomplished with redundant systems. Dual pumps with independent sumps and piping are recommended for each tank. The piping that runs to the building should be separated to allow exaction for repairs without disturbing the secondary pipeline. Design coordination issues for underground tanks include civil, geotechnical, structural and electrical issues. Here is a list of some of the most common issues. Access to tank location for delivery vehicles, geotechnical issues that increase installation costs, underground utility interferences, structural or foundation zone of influence issues, building wall details for piping penetrations, conduit or wiring definition for monitoring and control.